In this course, we're going to learn Godot virtual reality development, and we are going to look at how to get started building your first VR project in Godot 4. And you're going to learn things like how to add VR teleporting, VR climbing, adding hands, and interacting with the hands through the VR controllers. And we're also going to look at how to export our projects for web, so that way they are the most accessible, where anyone with a browser that supports virtual reality can play your game. And it is highly recommended to have a virtual reality headset, because that is going to have the best chance for your Godot project to be supported on that browser. You can also use web browsers on your computer if you have a WebXR simulator or emulator. However, oftentimes your Godot projects are not going to run in just an emulator or simulator. They do run best on actual virtual reality headsets in terms of playtesting. So if you want to most accurately playtest your project, we do recommend a headset. We're going to be showing the Meta Quest 3S used in this course, but you can follow along with any virtual reality headset. Many are supported by Godot. Virtual reality in Godot is still constantly being worked on, expanded, and improved. Right now, there are some limitations, especially with WebXR or building web games, compared to building just your regular integrated apps like that you would export for Android and that you would upload directly as an app into the headset rather than through a web browser. So you will find there are some limitations when building VR games for the web, but over time, more features are being worked on by the Godot team and just developers on Godot. So for this course, it is highly recommended to have experience with the Godot engine, as well as with coding, preferably in the Godot script language, GD script. If you want to take on the challenge, you can still watch, of course, with no experience, but some experience will be assumed when we start building out the examples in this course. We are using Godot version 4.3 and 4.4 beta. So either one of those two is recommended for following along exactly as you see in this course. If you're using a different version of Godot, you will likely see some differences with some of the editor or features. That's definitely possible. Virtual reality is a very exciting space for games. There's a lot of opportunity and limited games. So you can enter a niche market and you can be one of the first to make a unique virtual reality game. There's also some unique features of virtual reality that are not possible or not as impactful in normal games. For example, as we'll see with climbing, where you can really get that sense of height and fear of falling in virtual reality that you don't get in normal games. So we'll show you how to get started in this course. Other than the VR exporting and the VR interactions, like interacting with the controllers, and the VR movement, like teleporting or climbing, and the many other movement types in Godot. The general gameplay and the game mechanics or game development principles are going to generally be the same for developing in VR versus developing for a normal game. In terms of the programming knowledge required and the knowledge of setting up game objects. It's just in the specific interactions, movement, and best practices, as well as exporting that will be unique for virtual reality. Otherwise, you can take any game that you've built and you can convert it to virtual reality by changing some of the node types and the interactions. Or you can build out your virtual reality game from scratch without any base template or starter project. So you have options there. We will provide all the source files that are created and used in the course. So you'll have those to compare your project with the source files in case you run into any issues while developing. You will notice that developing for WebXR, which is virtual reality games in a web browser, there are limitations compared to what you can develop for OpenXR or other runtimes that are not on the web, that are offline. So do keep that in mind when you're trying out some virtual reality feature in Godot. It may not be supported for web games specifically because Godot is still developing out many of these features, especially for WebXR. And make sure you are using Godot, the stable version with GD script, because you cannot export for the web with the mono version using C#. That is a limitation currently in Godot. So let's get started. Coming up next. In this lecture, we will build a new XR project in Godot 4. Because we are building a web game project with WebXR, we need to make sure we're using Godot, the universal version, and that we are coding in GD or Godot script. We're using version 4.3 stable in this course. Let's choose a project name, such as our Godot. Here in the Godot application, we can create a project like Godot WebXR and choose compatibility as your renderer. Then you can select create folder to get a project folder created and press create and edit. This is going to launch a new project in the Godot game engine. You can create a new 3D scene, click and hit enter to rename the root node main. Press play and select the current scene as your main scene. Save and you'll see just a gray background so far. Next, let's add in some XR elements, starting with the XR origin. Right-click on the main object and add a child node. Search for XR origin 3D. This is the origin point in augmented reality or virtual reality. Hit enter, and you will get a warning that we need a camera child node and to enable XR shaders. So we are going to right-click on the origin and add a child node of an XR camera 3D. A camera node with overrules like location tracking. Hit enter. That will add the camera. Now we have to enable XR shaders. We are going to go to our project settings. Here you can search for XR. It's going to be towards the end. And in the shaders section, turn the shaders on. If we were developing an offline game, we would enable OpenXR, but in this case we only need shaders because we're doing virtual reality in WebXR. We have to press save and restart because we must relaunch the Godot engine if we made a change to project settings. Awesome. So now we have the XR origin, we have the camera, but the play still looks the same. We're also going to add our controllers. So I'm going to right click on the XR Origin 3D, add a child node of XR controller, a spatial node representing a spatially tracked controller. And in the tracker setting of the inspector window, we will select the left hand as the type of controller. You can also rename it to left hand or left controller. Whichever one the user has selected is what will be chosen, and it will be represented as a hand in the visuals. Then on the origin, I'm going to right-click, add another child node of another controller. In the inspector, set the tracker to right hand, and click on the object or the node in the hierarchy. Hit enter and rename it to right hand. You can also add some meshes to these, like you could add a CSG box just to visualize where these two are, but that is optional. If you run the game, you will not see the box just yet. Well, firstly, it has to be in the view of the camera, so you can select the camera and preview to see that the box is far enough away. And if you press play, you'll see the box appear. If you want the objects to have more of their true color, you have to add a light. So in our project, we're going to add a directional light. This is going to be just on the main object. Right-click, add a child node of a directional light 3D, which mimics the sun. Hit enter to add the light, and you'll notice that now if I am playing the game, we see the object is a bit brighter. And you can control the intensity as well. Next, we can add a floor to our world as well. So I can create a static body. I'll right-click, add a child node of a static body 3D, a physics body that cannot be moved by external forces. So I'll hit enter to add the static body 3D. It does need a collision shape, so we can right-click and add a child node of a collision shape 3D to handle collisions with the floor. In the inspector, you have to set the shape of the collision shape to some shape like a box. We can hit enter on the static body to rename it floor. Then let's give it a visual. So we will right click, add a child node of a mesh instance 3D, and take a look outside of the preview mode where that mesh appears. Okay, so we have this floor collision shape and this mesh. So there's that mesh that we see. We have XR Origin where we put in this box, but we don't really need that, so we can delete that box to avoid any confusion with the floor. In the Mesh Instance 3D, to see any shape, you must go to the inspector and set the mesh to something like a box. So this could be your floor, and you can click to expand the box, set its size like 10 by 10, and move it down so that it is below the camera. Press play to see that floor appear. So you can set whatever size you'd like for the X and the Z of the floor. Now the collision shape stays the same initial size. So what you can do is affect the collision shape size and also its position to make sure it covers that box. And on the box, you can of course change more of the properties. You can here create a new standard material for the floor, then click on its sphere to edit the material. Things like the albedo color can be edited. So you can click on the color swatch to select a value or enter in a value manually with a hex color code, for example, and then press play to see the changes in the world. Now, let's see here. If we don't see those changes appearing in our preview when we play, then go to the camera and hit preview to make sure that is working. And make sure you have your directional light as well. So we have our light here being added. Now we still do see this dark floor appear on that mesh. So to address that, I could add a world environment and create a new environment with a camera attribute and a compositor. Press play to see that lighting being added. So we combine the directional light with the world environment to see our result. So we have the floor in our world, but this is testing in normal mode, not virtual reality mode yet. What we'll do next is add a button that allows the user to enter VR immersive mode. And we'll have to have a script that actually enables the VR mode, whether it's WebXR in this example or another VR runtime like OpenXR. Let's continue our project coming up next. Next up, we are going to build a button that allows the user to enter VR mode. In our scene hierarchy, we are going to right-click on the main node and add a child node of a canvas layer. This is used for independent rendering of objects in a 2D scene. Our game is 3D, but the 2D scene or the 2D part of it is the user interface overlay that you can have in 2D. So I'll hit enter. Then I'm going to right-click on the canvas layer and add a child node of a button, just a regular themed button. And this is going to be our enter VR button, so we could change its name, so enter VR button. Then you can see the button if you are in the 2D tab of your project. And you can scroll up with the middle mouse button to zoom in on this button. You can enter text here, like enter VR, and then scroll out to see that button. By default, the font will be rather small. You can press play and you'll see that button at the top left-hand corner. To increase the font size of this button, we can go to the button object itself and we can increase the font size, and that is going to be in our theme overrides. So we are going to go to the control group and go to the theme overrides and the font sizes section. You can enable font size and increase the font size to a value you like, such as 100. And you can then also change its layout, like its anchors preset you can put at the center to center the button. Then you can press play to see that button on your screen. So choose a font size that works for you. Now we have to build a script that is going to handle the button press. When the user presses this button, we're going to take them from normal mode on the web page into VR mode if they're on a device that supports VR. This could be a browser that supports a VR simulator, or it could be a browser in a virtual reality headset. Let's build our script coming up next.